This video is going to look at converting units, specifically units that relate to gases. So I'll start with pressure. When you're dealing with pressure, there's a lot of different ways you can see pressure units written for gases. You could see millimeters Hg, you could see torr, you could see atm, you could see kPa. So kPa is your kilopascals. As we get further into gases, kPa is one that we use quite a bit. So it's definitely good to know how to convert from one unit to another. And this right here, this line, this equality statement here is what your key is when you're converting. So 760 millimeters Hg is equivalent to like 1 atm, or it's equivalent to 101.3 kPa. This is what allows us to convert it. We call it our conversion factor. So that's the key thing. So let's say we had an example of 400 kPa, and we wanted to convert that to atm. Right? So if I want to do this, I'm going to take my 400 kPa and I'm going to multiply by my conversion factor. And on the bottom, my conversion factor is what I'm trying to get rid of. That's the unit kPa, because that's what's attached to the 400 right now. On the top is what I want my unit to become. I want it to be atm. And then I look at my key up here for my conversion factor, and I see that 1 atm is the same as 101.3 kPa. So that's where I put those numbers. Then when I do the math on my calculator, I will get 3.95 atm. Right? And when we're doing this conversion factor, we want to keep whatever significant digits we had to start with. So 400 with that decimal, there's 3 significant digits. So I want 3 significant digits when I'm done. So that's how we can use our conversion factor. Let's try one more. What if we had 1,000 millimeters Hg, and we want to convert that into kPa? So we would take our number, 1,000 millimeters Hg, and we're going to multiply by our conversion factor, which is kPa on top, because that's what I'm trying to find, and millimeters Hg on the bottom. So 101.3 kPa is the same as 760 millimeters of mercury. That's what mmHg stands for. And that would give us, when you calculate it, 133.3 kPa. Okay, so that's how we can convert pressure units. Now let's take a look at temperature, because with gases, when you're dealing with temperature, we tend to see our calculations will be typically always using the Kelvin scale. So remember that the unit K for temperature is Kelvin, and that's your absolute scale. It goes from 0 up. There's no negative in that scenario. So when you're trying to convert a temperature that's in degrees Celsius to Kelvin, to convert that, we just take the temperature in degrees Celsius and we add 273. Okay, so if we were trying to look at, if we had negative 50 degrees Celsius and we want to put that into Kelvin, we just want to take the temperature in Kelvin is equal to negative 50 plus 273, and that would equal 223 Kelvin. Right? So the key with this is getting into that Kelvin scale, because whenever we're doing calculations, we don't want to have negative numbers introduced, so we're using this absolute scale. And then if you are reporting answers in temperature, a lot of the time you're going to have to convert them back to degrees Celsius for a calculation when you're done. So to go back to Celsius, we want the temperature at Celsius, we just take our temperature in Kelvin and subtract 273. So if I had 450 Kelvin and I want to put it into degrees Celsius, I'm just going to say that my temperature in Celsius is going to be 450 minus 273, and we would end up with 177 degrees Celsius. So that's how we can convert a temperature that's given in Kelvin into Celsius. With regards to significant digits, because we're adding, it's all about decimal places. So however many decimal places the numbers have, whatever's the lowest number of decimal places, is how many decimal places end up in our temperature for significant digits. So since I started with 50, there's no decimal places. I want to finish with no decimal places. Over here, I started with 450. There's no decimal places. I want to finish with no decimal places. So that's how typically temperature in significant digits would work. The last unit conversion we want to make sure we know how to do and deal with is our volume unit conversion. And in gases, we tend to talk about volumes either in centimeters cubed or milliliters or liters. You might see other units, but those are sort of the common ones that we see. So it's good just to remember what our units, or how these units relate. So remember that 1 milliliter is the same as 1 centimeter cubed. And remember that there's 1,000 milliliters in 1 liter, right? So if there's 1,000 milliliters, that would mean that 1,000 centimeters cubed is also the same as 1 liter. So if we were changing something like 75.2 centimeters cubed into, let's say, liters, we can use our conversion factor idea again. So we've got centimeters cubed, and we're going to use this relationship up in here, right? We're going to use this relationship. We know that we want to multiply by our conversion factor. We want to end up with liters on top. We want to get rid of centimeters cubed. So we want to find how these are related. Well, 1 liter is the same as 1,000 centimeters cubed. So that becomes our conversion factor. And we would get 0.0752 liters. And that's our answer to convert there. Okay, so that's just a quick volume conversion, very important. And then the only other piece that becomes really important when you're dealing with gases is sometimes we use a notation we talk about in a question. You might see them talk about STP. STP stands for standard temperature and pressure. So this is a set condition. Our temperature is 0 degrees Celsius, which is the same as 273 Kelvin. And our pressure is 101.3 kPa. So if you ever see a question and you're thinking, man, there's not enough info in this question to solve it, it is quite possible that they've said STP in there and you actually have more data than you think. Okay, so STP, standard temperature pressure, 273 Kelvin, 101.3 kPa. The other one you might see would be SATP. This is standard ambient temperature and pressure. This means the temperature is 25 degrees Celsius, which is 298 Kelvin, and the pressure is 100 kPa. Again, this is a set condition. If you see SATP, that's what it means for temperature and pressure. Okay, so these two pieces, STP and SATP, are important to know. They are on the back of your periodic table, so you always have those available to you. We use STP a lot more than SATP, but you should be familiar with both. Okay, so that's an important set of numbers for when we're working with gases. So that's the end of our video on unit conversions. Have a great day.